undo. And that's kind of the idea. As you get ready to start to undo things, we have to figure out how do you undo log base b of b to the x. We have to remember how do you undo, how certain things work. So remember, or I'm sorry, not undo this, this is how it actually works. Hello, good morning. So what happens here is, remember how log base b of the x, that log base b undoes the base b? So that's how you got the x to fall. That was one of the properties of logs. Same thing with exponentiating. When you exponentiate, you had this rule where you had b to log base b, that x value would drop as well. So what's going to happen is we're going to wind up using these types of properties as we solve the equations. And as you go through a lot of the equation stuff here, yes, for the most part, we have to remember how to press the buttons for the alpha window 5. Thank you. Thank you. So we have to remember the alpha window 5 to be able to get to change your log base stuff and go from there. But for the most part, this is going to be relatively straightforward. There will be certain problems that you'll have a little trickery to. Those will then tend to deal with a little bit more of the factoring that gets thrown in here. And as you see, there will be certain types that will be calculator based and certain types that will be non-calculator based. You'll be able to figure out which is which rather quickly. For example, let's say I want to solve this equation. Yeah, I wonder what the hint is.
Exclamation point.
You guys are, your knowledge is just superseding my expectations. So a lot of times with equations, you guys will notice you'll have numbers of the same variety. What I mean by that is you'll start to see numbers that could be generated via the same base. Okay. So when you start looking at a 4 and an 8, how can you rewrite them as the same base? Well, they both can be rewritten as base 2, correct? So a 4 as a base 2 is what? 2 squared. Okay. So this is the same thing as 2 squared times 3x. And then what's the 8 as a base 2? Now, are those the same bases? Yeah. What happens is if you get the same base on both sides of the equation, guess what happens to the exponents? They drop down. They drop down. You can go ahead and say that they drop down because if I do this, it's kind of the same idea. If I do log base 2 of this side, I have to do log base 2 of this side. What's log base 2 of 2? Remember how it undoes it? It just drops. So you don't have to do that step. As soon as you get the same bases, the exponents have to be equal. That's the trick. Okay. What's that?
Math is mathing.
Math is mathing, you're right. You wind up with 6x equals 3x plus 3. Pace yourself. Okay. What's x? 1. Good. It's not 7. Good try. You were almost there. Okay. Again.
4 only.
Yes, ma'am. What's that? 2 to the third is 8. Okay. And then obviously the one thing that most people forget, create the distributor to both parts. Okay. So it sounds like it's tough. You just have to set it up to get the same things. Okay. That's one of the methods it winds up with, and again, it's relatively straightforward. Sir? To show how you can undo it. Remember, if you have log base 2 of 2 and whatever would drop. But as soon as you have the same base on both sides, exponents got to be equal. That was one of the trick questions that was on the that log set thing that I gave you guys. Remember, I was like, what, 2 to the 215, 2 to the 215, 2 to the 215, or 215, whatever. So that was kind of tricky. You had to combine those two to get the exponents, set the two exponents equal to each other. Some of you guys were able to figure that out and make it work, so it wasn't too bad.
No. Yeah.
All right. So we'll do one more like that. We need 2. I'm going to do 2. Same idea. I have 9 to the 2x equals 3 to the x minus 6, and I need to figure out how to solve said equation.
You just like leave the 9.
Nope. You gotta do the bases.
Yeah, so if you leave the 9 the same, and then like the base.
Oh, I see what you're saying. No, because you have to. If you go that route, I don't think because if you go that route, what would happen to your x values?
It would be 2x and 2x and then
Right. Okay. So you want to rewrite to a common base. So if by squaring it, you'd have to square the other side to keep it balanced. See where I'm going with that? So that's why you have to go backwards. All right. So when you rewrite the 9 as a common base 3, this becomes 3 squared, 2x. And once again, are the 3's the same base? They are. Exponents drop. You wind up with 4x. Bless you. 4x equals x minus 6. This gives me 3x is negative 6. X is negative 2, I believe. So I always like to do this and always want to make sure I can double check stuff. If x is negative, that means that my 9 would be 9 to the negative 4th. You all right with that? Yeah. Okay. And if I put the 3 over there, that would be 3 to the negative 8th. Well, aren't those equivalent? Because if you go back to checking what the base is, as you go back and rewrite this 9 as a base 3, it does work. Okay. So you wind up being able to double check a lot of your answers without too much hassle. Okay. Not terrible? Alright. That's our first fact.
Oh, yay!
He always gets us to say not terrible.
What's not terrible? How is this terrible? You're awful. This whole situation is awful. I'm out of here. Bye.
like not terrible.
That would require me remembering a lot of calculus. All right. That's true. Anyway, 2 to the x equals 7. So basically what we have to do here is we have to figure out a way to get the x value out of the exponent. And we have to log it. But what log base do we have to do? 2. So in this case here, to get the value, this unknown variable out of the exponent, you have to log base both sides. So you would have log base, log base 2 of 2 to the x has to equal log base 2 of 7. So what happens on the left-hand side? You just get x, don't you? So that means your value of x has to equal whatever the log base 2 of 7 is. Well, depending upon if I want to let you have a calculator or not with something like this, I can have you leave that as an exact answer without a calculator. If I ask you to give me around 2 decimal places, this is when you press buttons. Okay. So in this case here, we have, what was it, alpha window 5, log base 2 of 7.
Oh, boy.
Round that to 2 decimal places, you get 2.811. Okay. Alpha window 5 gets you the log base. Okay.
I was going to get 2.
Alright. Let's make this a little bit more complicated.
Why not?
Alright. More than one step. Woo. So it's 10 to the 2x minus 3, all plus 4 equals 21. All right. What do you do first? Subtract 4. Good. So you have 10 to the 2x minus 3 equals 17. How do I drop the 2x minus 3? Well, I can just use log. Yes, you're about to say log base 10, and that's fine. If you use log base 10, that's okay. It'll still work. But here, since it is base 10, you can just log both sides. So if I log both sides, I'm just going to write out log form for one time. Log 10 of 2x minus 3 is the log 17. Left-hand side just gives me 2x minus 3 is the log of 17. Now, log of 17 is just some crappy decimal. Do you guys agree?
Yes.
Okay. To that crappy decimal, what do you have to do? And then what? Divide by 2. So at this point, you should be able to go ahead and just hit, now since it's just log base 10, you can hit log 17, but what do you have to, oops. What do I have to do after I do that though, first?
Second.
Parentheses, gotta hit the parentheses. All right, so this is going to give me some decimal. To that, what do I have to do? Add 3, so now right off the bat, I'm just going to hit plus 3. Hit enter, divide by 2, and hit enter. 2.16. Obviously, the rounding is going to get it really close to it. So if you go back and double check your solution with 2.16, 2.12. I'm sorry, 2.12. I was reading it as the third digit. If I go back and I use 2.12, so let's see, 10 to the, if I type this in correctly, this would be 10 to the quantity 2 times 2.12. Was it minus 3?
Minus 3.
And then it was plus 4? That's pretty darn close to 21 for me. You're going to be within rounding error, all right? And we're not going to like significant digits or anything like that, so 2 digits is fine. Okay? If I asked you to leave that as an exact answer, if I asked you to leave this as an exact answer, it would have been log of 17 plus 3 all over 2. That would be the exact answer. Okay? That makes sense?
Yeah.
By moving it around, no big deal. Okay. All right. Okay. Let's try this one. Very good. Well, it already has log base 3, so you get the 3. Yeah, 3. We just make up words when we can't figure out what we're doing, so it's what we do. So in this case here, we have to exponentiate it, okay? So on both sides here, you wind up turning these guys into exponents by putting a 3 there. Because 3 to the log base 3 of something, that's something that would drop. Does that make sense? Also, one of the other giveaways in a problem like this, you'll notice since it's just log equal log, the log bases are the same, the chunk in the parentheses has to be equal. Will this work if the bases are not the same? No. Nope, bases got to be the same.
What would you do with the basis?
Say nope.
You say no.
No, as well, no. You have to sing it when you say it.
So that's not.
No, you have to. If it's on the test, I expect you to stand up and say, "Go as bueno." Sorry, I didn't scare you.
I get too curious on what's going on.
Me too. So now I have variables on both sides of the equation. What do I do? Correct.
Yeah.
Thanks, Ken. We're not this
So here's the thing. I get x equals 2. What should I automatically do to make sure that this is correct? You doing electrical work?
Yeah.
Substitute. What's 5 times 2? Minus 1. 2 plus 7. So that they wind up equaling each other out, so it's going to be okay. All right, that's the idea. Always double check, make sure that your stuff balances themselves through. All right? Sir. Anything to the 0 is 1, which is 0. It's, oh gosh, how do you say it? There's a rule for it. And I remember seeing it, but I remember falling asleep probably during the long-winded conversation. So you can just Google it. I don't know.
Okay.
Now what do I do?
You do the same thing we just did.
Same thing we just did, right? So you wind up now, we get x plus 2 is x squared. What do you have to do now? Why would you square root it? That doesn't work.
What do you think? No.
Set aside equal to 0. And no killing of puppies, please.
I like the
I like the puppies. The puppies are very good. What times 1 is -2? I don't. I already put that on the side that I didn't want to buy a puppy.
That's why I said that.
Yeah. I didn't want to buy a.
Oh, wow.
Did I show you that yet?
No, but show us.
I will. All right. Anyway, so I will. I didn't realize you had already read the book, so I can do this now. What times what is -2 gets to -1?
I was the girl that he choked out. That's who I'm playing.
Oh God! All right, I gotta show you. All right. Anyway, so
What happened?
I don't know. Or I don't know. I'm thinking. In this case here, does my -1 work?
No.
Yes.
No, two does not work. Yes, it does.
What's -1 squared?
No, they do both work.
1. What's -1 plus 2? 1. So it's just going to be okay. All right. Now this is where things can start to get dicey when we get to quadratics, because you will get quadratics out of the log equations and stuff. So you always have to double check. That's why I keep saying double check your thing. Double check it. Okay. What are we doing on time? All right. We don't need this. This one's easy. Okay. Yeah, exactly. It's got a 5 in it. Notice you've got a log on one side and no logs on the other. How do I get rid of the log? I have to exponentiate. If I exponentiate one side, I have to exponentiate the other side. What do I exponentiate with? 5.
Who said 20? No. Oh, this
And x is? Okay. Once again, it's got to make sense if you think about it. What's log base 5 of 25? 2. Because 25 is 5 squared. The exponent. And by the way, this is really a word because it was in the textbook, exponentiating. It was a word. I didn't make it up. I thought it did.
Wow.
Oh.
Textbooks.
What do I do to both sides? To it. Okay. What's 2 to the -1? Well, isn't this the same? Can I get a seal? Isn't this the same? If you go to exponential, sorry, Sarah. If you go to exponential here, isn't that 2 to the -1 equals x?
Don't be funny to that.
Yeah, right.
Oh, yeah.
And that's a shortcut on this one.
I hate being like,
Now what do you gotta do?
Yeah, okay. You can't add those because they don't have the same.
Are we?
Oh, yeah. They're both.
In this case here, you have to condense prior to doing anything.
Oh, wow.
You guys see that?
It's almost like he was preparing us. Wow.
Who would have thought that I would teach you little bits and pieces to build up to something? Wow. Who would have thought?
Yeah, Kevin do
You're never gonna do that.
No. Why would I ever try to make sense out of anything?
I say we start from the top.
I say we're gonna make it bounce.
Yeah.
All right. So, according to this, this means I have to condense the one side. I'm gonna get a log of 5x times x minus 1. Now what do I do?
Find it.
10 it. Good. This is log base 10.
What?
So far, so good? Okay. Set aside equal to 0. Yep. What? Take the 5 out, makes your life a lot easier. Very good. So x squared minus 5x minus 20. I don't know. I was just checking to see if you're paying attention. Okay. No, it is more. Negative 5 more house in the 4. So we're back to here, which means we gotta check our stuff. Can I take a log of a negative number? No. Nope. So what do I have to throw out? The negative 4. I have to throw out the negative 4 in this case because I cannot take the log of any negative number. So then I wind up with the log of 25 plus the log of 4. Wasn't that the log of 100? Yes. And log base 10 of 100 is 2.
Wow. Magic.
Oh, oh, it's magic. Oh, I am really sorry I did that.
George.
Wait, just out. I got something to show you. This is the last one. Okay. Again, in this case, we have to condense before we can do anything. So you wind up with natural log of x, and then x plus 3 has to equal 1. How do you undo natural log? Okay. So I have to e both sides. All right. Now on the left-hand side, I wind up with x squared plus 3x equals e. Okay.
Wow.
Hold on. Isn't this setting you up for a quadratic?
Yeah.
Okay, so what do I do with the e? Subtract e from.
Oh, this is too advanced.
Then I stuck a knife in his head. Hey, what times what's negative e you add together to get 3?
I have no idea.
Neither do I. What could we use? Quadratic formula. X. All right, let's do the other song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, could I get a decimal out of this?
Yeah.
Sure. Yeah, you can put decimals in. You know there's an E button, right?
Yeah.
All right. So I'm going to type in I'll show you guys how to type in the positive value of this, then we'll see how we do with the negative. Okay. Let's see. So we have negative 3 plus square root of 9 minus 4 negative 3 plus square root 9 minus 4. Now the E button is second natural log, okay? But here's what you have to do. What's the exponent you have to put for E? 1.
Wait, can't you just do second divide? That just gives you regular.
Yeah, it does.
Oh, I forgot that was there. Yeah, that works. I forgot that one was there. So either one will be fine. All right. And then I would just hit enter. That gives me my numerator. And then what I would do is just hit. Oh.
What'd you do? Oh, that's not a real answer. So it's not really subtract.
So let's try the subtract.
No, that doesn't work.
Oh, we had to do that one first. So let's see. 9 minus 4. Oops. 9 minus 4. We'll try the other E button. Oh, it's negative.
What did you do?
You can't, so it's imaginary.
I just heard everyone.
You guys were like, screw it, I'm out. Did I? No. Oh, yeah, then I'll multiply. So that's not as weird. I mean, will you get crappy ones like this that will work that aren't imaginary? Yes. Just remember, if you have E in a set here where you've got to do some factoring, anytime you see an E in this scenario, plug down forward. All right. It just depends on what your A's and B's wind up being. Make sure it works. Yes. Yep. All right. I don't remember if I have another one. No. All right, let me get the problem here. It's pretty straightforward. I know the PDF is on there, so pretty straightforward. I gotta find it real quick.